welcome to Math News, where we explore how mathematics connects with real-life events. Today, we'll take you inside an exciting probability experiment conducted by the students of BSED 1C entitled Exploring Theoretical and Experimental Probability Through a Random Ball Draw. This hands-on activity helps us understand how probability works in theory and how it can look different when tested in real-life situations. Our goal was simple yet meaningful, to find the chances of drawing 3 balls of different colors from a box containing 10 balls, 4 blue, 3 pink, and 3 red. Let's now dive into the science of chances and see what we discovered. To start, here's Mariel Pascual to explain how we calculated the theoretical probability before doing the experiment.
Before starting our experiment, we calculated the theoretical probability, what should happen based on math. We had a box with 10 balls, 4 blue, 3 pink, and 3 red. We wanted to find the probability of drawing 3 balls of different colors in a single trial. First, we found the total number of ways to choose 3 balls from 10. That's 120 combinations. Next, we calculated how many of those combinations would give us 1 blue, 1 pink, and 1 red. There were 36 such combinations. Using the formula for theoretical probability, number of favorable outcomes over total number of possible outcomes would be 36 divided by 120 is equal to 0.3 or 30%. This means that according to the theory, we should expect about 3 out of every 10 trials to result in 3 different colored balls. With the math in mind, we move on to the experiment itself. To test our prediction, we did a simple but careful experiment.
We placed all 10 balls into a box and thoroughly shuffled them before each trial. Without looking, we randomly drew 3 balls and recorded their colors. After each draw, we return all the balls to the box to keep the conditions the same. We repeated this process 30 times.
Now, let's look at the data we collected and what it revealed.
Thank you, Mariel. After conducting 30 trials, we recorded how many times we drew 3 different colored balls out of the 30 trials. This happened 14 times. To find the experimental probability, we use this formula, number of successful outcomes divided by total number of trials, equal 14 divided by 30 equals 0.465 or 46.7%. That's higher than theoretical probability of 30%. Let's now look at why the number were different.
Thank you, Marian. The variation between theoretical and experimental results is common, especially in small experiments like ours. Here's why random chance with only 30 trials, unexpected results can happen. Human factors, the way we mix or drew the balls might have affected the outcome. Sample size, more trials would likely lead to results closer to the expected 30%. This shows us that why probability gives us a guide, real-world results don't always match perfectly. Let's now wrap up with some real-life application of what we've learned. Probability is everywhere in predicting the weather, setting insurance rates, business decisions, analyzing sports strategy, and even in healthcare. Understanding both theoretical and experimental probability helps us make smarter decisions every day.
It's also helped us understand that math isn't just about number. It's about solving real problems and making better decisions.
It reminded us that numbers are more than answers. They are tools for understanding the world.
Thank you for joining us on Math News for our report exploring theoretical and experimental probability through a random ball draw. I'm Eunize Lei Anne Quiaoit, provide insights about the topic.
I am Mariane Tuazon, reporter of Data Collection and Experimental Probability.
I'm Mariel Pascual, reporter of theoretical probability.
I am Rish Angeles, reporter of analysis of results.
On behalf of BSED 1C, thank you for watching.
Stay curious.
Stay mathematical.
And keep exploring.
See you around!